Okay, good. So if I look back at the study guide, we have many techniques for strategy analysis. I think the most difficult one I explained to you. Is there anything else you would like to know from the techniques part? Uh, so, for example, these are the other ones that we have. Balance scorecard, business capability analysis, business case, business model canvas, SWOT risk. I trust others are something which you can read and understand. They're not that hard. So please do that. And maybe tomorrow, if you have any question, I can still answer. So now I'm switching to one of the big topic, which is the UML. And let me spend a little time in explaining the different models that are there in UML, because usually you would be expected to answer questions based on UML diagrams. So I will take this one. Okay. So how did this term called UML came? So if you understand what's language, Davis, how do you define something as language?
A way to communicate.
Correct. A way to communicate between each other. That's language. So we call English language or Swahili language or whatever language. Using that language, we can actually communicate between each other. Then what's modeling? Tasa? Gopi, what's modeling?
Modeling is a pictorial representation of language.
Okay. Modeling is basically using diagrams, symbols to represent something. So a modeling language actually uses different kind of icons to communicate information between stakeholders. And obviously a modeling language would express information using icons. And why do we model, Gopi? What is the reason that we model?
Because it's easy to understand.
Yes, one, it is easy to understand. Two, it is less ambiguous. That means when you write things in textual format, people are likely to wrongly interpret it. Whereas a picture is less likely to be wrongly interpreted. And you can also follow rules. When you model, you can have very strict rules about how the icons are put. What does an icon mean? So if you are aware of the modeling language, your communication will be much more clearer. So what is this term called unified? See, in about 1970s, different business analysts, thinkers, they started creating different modeling languages, and there were many modeling languages in the market. Obviously, more modeling language means more confusion, because the same information was being presented in 2 or 3 different ways. So these authors actually came together and they decided to create something called an unified modeling language, which means all of them agreed to a common syntax. And then they formed an organization, which I think all of us should know. It's called Object Management Group, OMG. And this is the organization which actually spearheads all the modeling related information. So here you will find unified modeling language as well, which is what we are going to study. But it actually does a lot of work, not only UML. See, if I go to popular OMG standards, And these are only popular. There are more actually. So there are things like BPMN, which is also quite popular. Then UML is of course quite popular. Then there's SysML, then MDA, then DDS, and there are so many different standards that these guys put up. If any one of you are working in mission critical software, like aviation software, automotive software, healthcare software, then OMG is a great site to actually refer to. There's a whole lot of content on critical software. If you look at BABOK, BABOK is mostly for commercial software, like the application software that we talk of, like a CRM, ERP, or any kind of management system. That's what BABOK primarily focuses. It does not get into a depth of high secure system, high reliability systems. It doesn't, because that's not the focus of BABOK. And about 95% of us work in the commercial world, but there could be 5% of us who are working in mission critical software world. So if you are in mission critical software world, OMG is a good place to visit and spend some time. We actually wanted to become a member of OMG, but it's very expensive. I trust at some time they will make the membership a little bit more affordable, so that more and more organizations can actually join them. Okay, back to our discussion on UML. So in UML, we actually talk about different kinds of diagrams. So the ones which I have shown in green are the ones which we use quite often and mostly prepared by the business analyst. The ones which I have put in red are mostly created by our technical architect, but of course we use them and we need to understand them. So from that perspective, I call them as more technical than the other ones. So the first one is the use case diagram, which I believe a lot of you would have seen. So it talks about use cases, actors, scenarios. So usually used for functional behavior of a system. And this is how typical use case diagram looks like. So you have something called a system boundary, which is what I have drawn it in red. Then you have use cases within the boundary. You have actors, and here I have put a non-human actor in a slightly different way, but you can also use the stick-like figure if you wish to have. And then there is association between an actor and a use case. Okay. Then we have two special kind of associations which we need to understand. One is include and one is extend. So let me show you the two relationships. 1 second. The same diagram. Okay, one we call it a base use case, and the second one we call it as an included use case. So what is an included use case? An included use case is typically an use case whose functionality can be used by many use cases. So let me write that down. Maybe that's a helpful tip for all of us. And included use case is a use case whose functionality can be used by many other use cases. So in a sense, the included use case allows us to reuse functionality. That's the main beauty of an included use case. That means we would have other functionalities which we can reuse. Okay. And this is how typically we read it. Use case A includes the use case B. That means it includes the functionality of use case B. Okay. Just to give you a very simple practical example, how you can think of this aspect. So let me take you to our application and show some real example of include use case. Let it come. It's a bit slow system. You just have to bear in mind. Okay, so I go to our product BU and go to project management. Oh, no, not this one. I think I should have gone to the project. Say, for example, we have a requirements module. Okay. Now, of course, we have merged the requirements and backlog together. Now, is it necessary for us to assign a team member to the requirements module? Ron, do we need to assign a team member to a requirement?
Not at this stage, I don't think. I think it comes later on, doesn't it?
But at some time we have to assign somebody to work on the requirement.
Well, the requirement itself instead of implementing. Okay.
Then suppose we have a backlog item, which is basically a defect. Do we need to assign a defect to a particular person?
Yes.
We do need to. Okay. Now we have an action item, which is your item tracking, what Babak calls. The item tracking also needs to be assigned to somebody because somebody will actually work on it. Okay. So everything that we do in this product needs a functionality that something needs to be assigned to someone. And that you can write it as a common function saying assign team member, and you can use it in any of these modules that you wish to have. So that's a
LN, is this a requirements management software you're viewing?
Yes.
Through Adaptive?
This is our internal project management tool.
Oh, project management tool.
Yeah, we have a simple project management tool, not very complicated one. We basically track, nothing else. We have to track our defects. No? Customers raise defects and we raise new requirements. So all those are tracked here. Like this one seems to have come from a customer. That's why we don't have the email ID here. We have to really find out. But this is something that was raised by me for my colleague Princey. This is again another one raised by me for my colleague Fatima. Different people pick up different things because they have different specialty or skills. Okay. Good. So this is what we call it as include. Now we have another interesting association which is called extend. An extending use case provides additional functionality. So let me write that down as well. An extending use case provides additional non-mandatory functionality. That means it gives you some extra thing to do, and we read it in this way. Use case B extends the use case A. So this is what is called the extension, and in this case the arrow goes towards the base use case. In include, you will find the arrow goes towards the included use case. Okay. Any question on this use case diagram, include, extend? Amar?
Sorry,
Nidhi, go
I
ahead.
have a question. Yeah. So means to design a use case. I'm just giving you an example with like about adaptive 3 different plans, like CBAP plans. So if you are designing 3 different plans like basic and advanced and ultimate, so in that, like if I am getting like advanced, so you have to design use case B in that case, because we are getting like extended, additional features.
No. That is up. What you are getting is some additional content. This is additional functionality in the system. So if you look at, say for example, if I take a very simple use case for us, from a succeed perspective, it will probably be some of the use cases that you will find would be, say, if I just take this is my boundary for the time being. And let me just kind of format the shape, no fill. So the common use cases that you will find in this particular product would be create courses. We create different courses, create courses, and a course may have many plans. Okay, plans are not mandatory. For some courses, there may not be plans. So plans are optional. So we will say, sorry, this one saves. I will take this and connect this to this. That means plans are not mandatory, but courses are mandatory. Okay, a course may have a plan, may not have a plan. Then we would also have other use cases like create users. Then we would have an extension for this would be assign users to courses. Assign users. That's again an extension. You could think of some include use cases, but you have to really think what are the common functionalities that you can use. Say one of the common functionality that you can think of as an include use case would be uploading course data. Okay, suppose you want to upload something into the system. So you will find, when I go back to our product, you will find a lot of uploads. Uploads are nothing but an Excel file which you can directly push it into the system. Instead of adding data one by one, which is very cumbersome, so we have created some kind of import templates which you can use to upload data. So the data could be upload question, upload options, whatever, you can do that. Okay, so those would be a functionality which you can reuse. Like say for example, I could always create one here. Sorry. So I could create this one, upload Excel. This use case can be used by both these use cases. So I could actually put it here. You can use a better software than using PowerPoint. PowerPoint is not a great software to create use case diagrams. You should use VCO or some other tool, but it's okay. I think PowerPoint is also not that bad. And then similarly, you can have a relationship between this and this as well. So these two relationships are include, these two relationships are extend. So if you want to draw a succeed use case diagram. Of course, there are other functionality as well. I'm just showing you very simple ones like create users. There could be another use case which is attempt quizzes. Attempt quizzes. So who would attempt quizzes? So if I take a human-like figure from here, from the other diagram, let me take the human-like figure. So if you take it here, see obviously who is going to create courses and all? Who will create the courses?
Providers.
It's the faculty. The faculty is
faculty,
interested in creating courses. So the faculty would be associated with this user course creation. So this is faculty. This is the course admin. Okay, this is the course admin. This is admin. Who will attempt quizzes? Participants. Obviously. So you are the participant, so you will be represented like this. Participants. So this is how you can quickly draw these use case diagrams. Of course, I can kind of push these things a little bit up so that they look a little nicer. Right now they don't look that nice. Maybe I'll center align it, and maybe I'll put it somewhere here. All that you can do it at your leisure time. Okay. Just wanted to show you how you can do it quickly. But don't put too many boxes in one particular place because it makes it very cumbersome. So keep it at 2 levels, 1 level, 2 level, so that you don't have to really make it very, very cumbersome. Okay, Gopi?
Yeah.
Okay, good. Then we go to our next drawing, which is after use case diagram. This I explained to you, include, extend, and there's actually a very good book by Howard Podeswar in IIB Online Library. This is the book that I used extensively to kind of learn about UML, because I never used UML in my work life because I came from a different BA background. I came from an ERP implementation background. Now, of course, I do a little bit of it for our own product. Otherwise, those days, it wasn't required to create all these diagrams. Okay. Then there is something called an use case description, which is fundamentally writing steps. So there's a short video that I have created on use case description. Let me show you that, and then I will continue from there. This video should be there in the tool itself, but where in the tool I really don't know. So let me go to source. So this is what I called it as use case template. It's what Baba calls it as use case description. Is it playing?
Use cases are a very popular technique to describe features of a solution. Key concepts behind use case are actors, users, who use the system, and use cases, functions the system provides. Let's understand use case with a very simple use case, the login use case for a product. Each use case has a goal. The goal is what the use case tries to achieve. For example, here the goal is to provide access to the application for the authenticated users. Use case has a precondition, which indicates conditions to be satisfied prior to the use case. For example, the user needs to have a legitimate login profile and password for using this use case. Success end condition indicates the end state, if the use case is successful. Here success end condition is to get access to the home page. Failed end condition indicates the state if the use case fails, say to redirect the person to forgot password page or lock the account. Primary actor indicates to an actor who initiates the use case. Secondary actor participates in the use case once the primary actor initiates the use case. For example, the password may be reset by administrator if the password is locked. Trigger indicates how the use case gets activated. For example, this use case gets activated when the user clicks on Login button. The activity description provides steps of the processing. For example, here user visits the URL for the login page. After that, the user inputs profile and password and clicks on the Submit button. Then the system validates the inputs and accepts or rejects the login. There can be branching actions or exceptions in a process. For example, if inputs are incomplete, the system may provide the alert message indicating the user has not provided the username or password. Use cases can have relationship with other use cases. Use cases also can have priority, which indicates how critical the use case from the business perspective is. One can also mention specific performance requirements and assumptions for the use case.
Okay, so this is what people call it as use case description, use case template, use case specification. They call it in many names, but fundamentally this is what we put into an use case description. Okay. Then there are also terms that people use. One is called the happy path, the alternate path. What are they? So let's understand them. So suppose everything goes okay in a process, nothing goes wrong. That's what we call it as happy path or success path. Nothing goes wrong. Something goes wrong, but you still can complete the transaction. Like say for example, in the login case, you first time entered your username properly, password properly, and you got in. That's success path. Now you made a mistake in your password. The system alerted you saying that the password is incorrect, and then you corrected the password, and then you got in. So you actually followed a slightly different path because you did something wrong, but you could recover. Then sometimes the system is not available and you are not able to complete the transaction. That is what we call it as an exception path. Sometimes server is not available or something else happens and the system says, sorry, I can't do anything now. Please come back after half an hour or after some time. Okay. Maybe the load is very high on the server. So the server gives you a message saying, no, I can't handle it right now. Please come back at a later point in time and try the transaction. And we would have a concept called a rollback, which means suppose I have moved a little bit in the transaction, but the transaction fails. Then I have to come back to the original position, which is what the technical guys call it as rollback. Good. Then we move to our next diagram, which is called the data model. And in data model, we have two kinds of diagrams. One, we call it as ER diagram, entity relationship diagram. And we used to have a tool called Irwin, very popular, about 15 years back. Then today, we have moved to a new diagram called class diagram. So let's try to understand the similarities and difference between these two diagrams. So let me put this diagram here. So one diagram is here. So this is our ER diagram. And we will also take the class diagram. Good. So let me make it a little smaller so that I get a little more space for my class diagram. Good. So let me ask this question to Max. Okay. Max, what similarities do you see between these two diagrams?
Well, they all have the relationships.
Mm-hmm.
They all have the class.
Mm-hmm.
And they all have their attributes.
Very good. Okay. So I think Max found very nice, interesting things. So if you look at ER diagram, you have entities, and those entities basically become classes when we call them as class diagram. Then you also have attributes in both. You have association in both. You have multiplicity in both. Multiplicity basically means how many elements of the other entity are related to a particular entity. So for example, if you are taking a look at order and customer, you'll find that one customer can place 0 or many orders. Whereas when you look at one order, it is always associated with only one customer. That's what we call it as multiplicity. These are there. Okay. Now Tasa.
Could you
Sorry.
could you repeat the comparison again while pointing on the diagram about the entity, class versus the different definitions of each diagram? I just want you to point at the object as you go through, so I can better have make sure the definition I have in my head is correct.
Okay, let me just take it.
Thank you so much.
No issues. Okay, this is an entity. Okay, an entity has a name and of course has some attributes, which are the properties of that entity. Like an apparel would have a size, would have a code and some sort order, how the apparel has to be sorted. Okay, the same thing becomes a class in class diagram, but it is slightly different from an entity. How? The entity had only attribute, whereas the class has attribute plus methods or operations. So in a sense, a class is more powerful than an entity as a concept. Okay, Muhammad?
Perfect. That's all I needed.
Very
Thank you.
good. Then the notation that you are seeing here, actually let me make it as big as I can, because that will make it easier for all of us. Let me kind of close this guy out and let me kind of take this guy down. I can't. Okay, whatever I can. This is called a crow feet notation because it looks like crow's feet. And the crow feet notation has a symbol which is similar to this. I'll show you. This is called one and only one. This is called one or many. This is called zero or many. This is zero or one. These are the symbols that we use. You can also present them using this kind of numbers. You can also use symbols, like sometimes we put n.m. Okay, you can also put 1.n, which is also okay. You can also call it as 1 dot star, which is also okay. People use different notations, so there's nothing wrong or right. N would mean a number, and it could start with 1, it could start with 5, whatever, something. Okay, so 1 dot star means minimum 1 and maximum any number. So, but in class diagram we usually use this notation, not this. You can use, but not very popular. Okay. Then you see the association between one entity to another. And what I was trying to explain is when you want to understand the multiplicity, look at the far end. Like from customer, you look at order. What is the number that you see? You see 0 dot star, which means one customer can be associated with 0 or many orders. Okay, by that logic, one order can have how many payments? Let me ask this question to Ilham. Ilham, how many payments can be associated with one order? Ooh, Ilham, are you there? Sorry, Iris, would you like to answer that question? far end. From order, look at payment. What is the number that you read there, Iris? Not able to hear you, Iris, for some reason. Maybe check your mic. One too many. Correct. One. It's actually read as minimum one, too many. Okay. So at least one. Okay. That means an order must have minimum one payment, but can have many payments. Very good. Now there are two other symbols which this diagram also uses. One is called generalization, and one, actually it's not pointed here, this is called composition. It's somehow missing in this. I think in the other diagram I have put it. So if I go back to the other PPT, there you will find. This is called composition. So what is composition? A composition means one class has many child elements of the other class, like an order having many order details. That is a relationship which is called as composition. Then there is also a relationship called generalization, which means there is some property which can be put it into an abstract class. So for example, here we can pay through credit card or cash or check, but all three payment methods will have a common property, which is amount. What is the benefit of doing this? Why should we create an abstract class? Mohammed?
To give multiple options to the customer.
I anyway can create three classes, Nidhi. I anyway have created three classes: credit, cash, and check. Three options. Why again one more class called payment?
Talking about the order detail?
No. Payment versus credit, cash, and check. The generalization relationship.
There are three methods of payment.
No, but payment itself is a class.
Could you repeat the question, please?
No, I'm saying, what is the need to create a payment abstract class? I could always say payment credit, payment cash, payment check. That's it. Three classes.
Because that's
Yes,
they all
Tasat?
have different attributes.
True. They will have different attributes.
The generalization of all the types of payments.
Okay, now suppose, think of a scenario. Tomorrow, US government says any transaction above $1,000 must have social security number associated with the transaction. Suppose the government comes up with such a regulation because government would like to know where people are spending money, where are they earning this money, are they getting it through legal means or whatever. Then I have to implement that rule here. I don't have to implement the rule 3 times in 3 different classes. So in a sense, an abstract class also enables us to reuse functionality. Like we talked about the include use case, the abstract use case, abstract class is also very similar in concept, that it allows us to reuse functionality. Okay. Now coming to this operations usually have many methods. So some of the common methods are CRUD, which we already know, create, retrieve, update, delete, but you could also have import, export, alert, other functionalities as well, depending on what your customers are looking for. Okay. This is, I think, a very complicated diagram. Let's stop here. I would like you to take a look tomorrow, through this day, spend another 5 minutes on this diagram. And if you have any questions, I would answer them tomorrow. Because I know this diagram can become a little heavy for many people. It was quite heavy for me as well. Okay, good. So I talked about association. Then I talked about aggregation. I talked about generalization. talked about multiplicity. And finally, there is also a term called navigability, which means from what direction you search. So that means the order detail class searches the item class. That is why there is an arrow pointing towards item. And the reverse search doesn't happen. Okay, so that is what we call it as navigability. Yeah, then this is what I was explaining you, 0 dot dot 1, 0 dot dot star, or simply star, 1, exactly 1, 1 dot dot star, at least one instance. Then we come to a simpler diagram, which is called activity diagram. And activity diagram, I think all of us would have seen, done. So that shows the tasks that happen in a process. You, of course, have a start node, an end node, which are called terminal nodes. Then you have something called a fork, from where different tasks begin parallelly, not necessarily at the same time. Don't think that they're at the same time, but they happen parallelly. And then, of course, there is join, where again multiple tasks converge. And then you also have a decision box. So let me put this as well. I think I forgot about this. This is the decision box. Where do I put it? I think that symbol most of us would be familiar. So this is the decision box. Which allows us to make some kind of a check and go forward, go in this direction, all that kind of thing. Okay. Then we also have another diagram called BPMN diagram, which is also known as swim lane diagram. And there the difference is here you show the actors as well. In this diagram, you are actually not showing the actors. You're only showing the tasks. Whereas here, you're actually showing the tasks as well as actors. So which is better, swim lane or activity diagram?
BPM.
BPMN is obviously better. That's why more and more business analysts are using BPMN diagrams.
At one point, these were called multifunctional or cross-functional process flow charts.
Yeah, true. Yeah.
Which one is the original name? This one or the other one?
I think BPMN has been there for quite some time. I think CFPM I have heard. I know my colleagues used to use CFPM. CFPM training certificate. There are a lot of things. I don't know. This is certified food protection manager. This is different. This is cross-functional process map. This is what we used to call it as CFPM. It's just almost look very similar. Maybe just a different name, but maybe the difference between CFPM and swim lane would be something like this. If you look at CFPM, what do you find in the leftmost column?
Your
departments.
I would say the stakeholders, yeah, or departments.
Departments mostly.
Yes,
and I think the intent behind cross-functional process map was something like this. What I remember is when there's a process that goes through multiple departments, usually there is a failure in the handover. That means when sales hands over things to purchasing, purchasing hands over things to somebody else, that is where the process actually fails. That is why they
That's why in the future state map we usually the point for my usage anyways of applications from a lean background, we'd use this for the current state map with multiple departments handling data. And then you would hope in the future state you'd have a lot less rows and less boxes with some automation.
True, possible, yes. I think that is what you're talking is as is and to be. Your
Yeah,
as
correct,
is process and to be process, which is where what you're trying to say is today I do a lot of things manually. Tomorrow, can I do it automatically? And in fact, it was very interesting. I got a mail a little before. Okay, so this is one of my colleague, and he sent a mail right now. I mean, the system sent a mail, and he's definitely not working today. It's a Sunday. Why would a development guy will work on a Sunday? But this mail has come because what we wanted to do, we wanted to do a regression test, automatic. So that's what he has implemented. So every day at a particular point in time, it would actually send a mail that it is trying to do all the transactions online, and the final outcome of the transaction is this particular mail. So we know, okay, if this mail comes, the system is safe. It is being, it's active and it's not having any trouble. If this mail does not fire, then we know there's some problem in the system. So we want to get alerted before customers tell us that your system is down. And it's very hard for a normal tester to keep testing every day. It's irritating. So we kind of deployed one small open source tool called Selenium, and using Selenium we are able to do this part. So I'm glad that this was our actually a plan for quite some time. It was there in our plan for quite some time to do it, but finally it has started working. Because the more work you can give it to system and free up people, they can do other things. Good. So I think they look very similar. I think, Mohammed, it doesn't matter what you call them. Just that probably CFPM was very popular 10, 15 years back. I don't hear that name much more today. I hear a lot more about BPMN today. And sometimes a new name always helps because people think it's new. and that acceptability becomes a lot more.
Yeah, just like TPS, Theory Production System. Now it's called Lean.
Yeah. Even if you look at Agile, whatever we call Agile, it has been talked in 1930s. It's nothing new. There was one gentleman by name McGregor. He proposed Theory X and Theory Y. And Agile guys borrowed Theory Y and they gave it a new name and they're making a lot of money out of it. Okay, no worries.
So
we'll go to our next diagram, which is called data flow diagram. And I think many of you would have seen this diagram. This is quite simple. So you have something called a source, which provides information. Then you have a sink, which receives information. You have a data store, which stores information. And then, of course, you have your data processes, which modify the data. Do something with the input data. And people also tell that there is a diagram called context diagram, and a level 0 DFD is also called a context diagram. So maybe let me write it down here. It will be part of my PPT for all the time. A level 0 DFD is also known as context diagram. I think PowerPoint becomes smart enough not to take me outside the box and bring it back. Okay. Good. Then we have something called a state diagram, which talks about the different statuses that we have for any entity and how do the states move or statuses change. So here is a bug life cycle. A bug is opened, it is assigned, it is fixed, it is implemented, and it is finally closed. In between, you can decide to cancel the bug as well, and that becomes an alternate status. So from some statuses or states, you can move to a particular state, or you may not be allowed. Like, say, for example, once a bug is closed, it cannot be cancelled. Or once a bug is implemented, it cannot be cancelled. So you have a lot of tools now available for you to create this kind of diagrams. You can use MSVCO, you can use Lucidchart. There's also an open source one called Star UML, which also you can use for creating all this kind of diagrams. Then finally, one more technical diagram, which is called the sequence diagram. And in a sequence diagram, we basically show the interaction between various objects in a system. So if you see this particular diagram, we are talking about a hotel reservation system. So we have an user interface that sends a message to the hotel chain object. The hotel chain object sends another message to hotel. The hotel object sends it to reservation. And finally, we have a confirmation. And this is the period during which the entity or object remains active. That's why we call it as an activation bar. And this line is called lifeline. So at this point in time, the transaction is completed. So the transaction can be considered as closed. I also haven't created any sequence diagram for my BA work. I think this is mostly a technical work because you can read like void and boolean. These are terms that developers actually use quite a lot. What does void mean actually? It's a programming stuff. Anybody knows? I see this void quite often in programming language. Boolean I can understand. Yes or no?
It's a value that's not set to anything.
Ah, okay.
It's like it's unset. So like if you have yes or no, you can also have no. It just gives an indication to the back end that that value isn't set to anything.
Ah, okay. So it can be anything. It means including being null. Okay, maybe Ron knows.
Yes, it's not one of the final set of outcomes. Yeah,
okay. I'll leave it to you guys. If you know it's well, I don't bother. I don't think in the exam we will ask anything like that. Okay. Good. So this is a quick intro to UML, which I wanted to do for you. And maybe it's a good time to take a short break because this has been quite intense today. I can feel it. So let's take a 15-minute break. We will come back, do some case questions from this knowledge area and from other knowledge areas as well. Whatever time permits, we will do that. Okay.